Greetings everyone and welcome to the Maang channel. Today we will be discussing the basics of database transactions, what they are, how they work and why they are important. So let's get started. Let's try to first understand that when do we need transactions. So let's say we have two users, user A and user B, and user A has to transfer $10 to the user B, and they have a bank, and in the bank you have a database where their balance has been stored. So user A have a balance of $100 and user B have a balance of $100, right? So now to transfer the money from user A's account to user B account, what is going to happen is that we are going to debit $10 from user A and then credit that $10 to user B. How we'll do is that like subtracting $10 from balance of user A and adding to the $10 from user B. And once these two statements gets done, ideally our database should be having this state where user A have a balance of $90 and user B have a balance of $110. Right? Good. All good so far. Now, what if database crashes after the first update? So in that record, that means that money has been debited $10 from user A, that becomes 90, but the second has not been executed. So the B remains 100, right? And when database recovers, you still have the same state that user A has $10 and user B have 100. That means that that $10 just vanished in the air, right? So these type of problems can be solved using transactions. Now let's take a look to understand what is transaction. So in a transaction, you typically have a set of steps, right? And they are executed as a single unit of work. So if any one of the step fails, the entire transaction is rolled back, meaning that all the changes made up to the point of failure, they are undone and database is left in its original state. This ensures that database remains consistent and accurate even in face of errors or failures. Transactions usually provide a way for an applications, right, to group the several reads and writes together into a logical unit. Either unit will succeed or fail, and if it fails, the applications can safely retry. So let's revisit our banking example where we had two statements that we were trying to execute, and we saw that if the database crashes after the first statement, what happens? But if we make this unit of work as a single unit, that means that now either both the two statements will succeed, and if first one or anyone fails, the entire transaction gets rolled back. So that means that now if I retry, if the transaction fails, I can safely retry and nothing will happen. On the other hand, and previously, if we keep on trying multiple times, those $10 will just vanish in the thin air. Now, let's take a look at what are the properties transactions have. They are like secret spices in a recipe that make sure that database does not turn into chaotic soup. They are the rules that keep your transactions on track no matter how many errors, failures, or rascal users try to mess things up. In other words, they are like your superhero capes for your database transactions and making sure that they always maintain their integrity and consistency even in the face of dangers. The key transaction properties, they are atomicity, consistency, isolation and durability. These four properties they have called a acronym that call like they call acid properties, and together like these properties ensures that transactions are executed reliably, consistently, and maintaining the integrity and consistency of the database. Now let's talk about the atomicity property. So atomicity property, this ensures that a transaction is treated as single indivisible unit of work. Like all the operations within these transactions, they are either completed successfully or rolled back in case of failure, so that database remains in a consistent state. So one thing to note that is that atomicity has a different meaning in different contexts. So for example, like when it comes to multi-threaded programming, and they have the atomic operations like a magician's trick that makes sure nobody sees the half finished results. Once a thread executes an atomic operation, there is no way for another thread to catch a glimpse of the in between state. It is either the state before the operation or after, but never both. However, atomicity in the acid property does not necessarily guarantee the concurrency, which refers to what happens when multiple processes try to access the same data at the same time. This is where the third property, that is isolation property, comes into play. In case where a client wants to execute multiple write operations but experience a fault before, just like we saw in our bank money transfer example, say a process crashes and there is an interruption in the network connection, and it's important to have a fail-safe mechanism in the place. That is where the atomic connections come in handy. By grouping the right operations together into a single transaction, the system ensures that if the transactions cannot be completed due to a fault, it can be safely aborted. That means that database can discard or undo any writes that have been made so far, enabling the applications to retry the transactions if needed. Think of it as like a safety net for your data, catching your errors that may arise and allow you to give it for another go. Now let's talk about the second property, consistency. And believe it or not, I found that the consistency term is like one of the most confusing and overlaid term I encountered. The more I read about different distributed system articles, the more I have the confusion. So for example, like you have a consistency around replica. Like when you copy the data from primary database to secondary database, you're replicating the data. And then there have a concept of eventual consistency. And then there is something called consistent hashing, where this is approach to partition the data to multiple databases. I didn't understand like why the word consistent was there at all. And then you have a cap theorem that says that the word consistency is meant to linearizability. So in your interview, if you're using the word consistency or has been asked about consistency, make sure you really understand what actually you mean to say and what the other person is asking mean, because people have different meanings when they say consistency, so you should always try to get some context what actually they mean when you say consistent. I think I had three instances where every time I have used the word consistent or consistency, I had been asked a counter question, what actually do you mean by that? So just be careful. So next, say let's move that this consistency property, it ensures that the transaction brings the database from one consistent state to the another consistent state, and database must satisfy all the constraints and rules defined by the schema during and after the transaction. Now the question could be, what is the consistent state? Let's say we have our banking system where all the debits and credits across all the users account needs to be balanced. And this idea of balance actually belongs to the application. The database does not know anything about the balance. So the word consistency or the property is actually a property of application, and the application needs to define the transactions accordingly. Applications can rely on databases property of atomicity and isolations to achieve the consistency. Now let's talk about the isolation property. So isolation property, it is like creating a little bubble of protection around your data. And you see, in a database system, multiple transactions can be happening at the same time and all vying for access to the same juicy bits of data. Now you don't want one transaction to come along and messes up all the hard work of another, would you? That is where the isolation comes in. It is like putting a barrier around each transaction so they don't interfere with each other, and each transaction gets its own little sandbox to play in with its own toy to manipulate, and no one else can come in and mess things up, right? It's like being a party where everyone gets their own little corner to dance in, and you cannot step on each other's toes if you are all in your own little world. This isolation is also called as serializability in database texts. Now let's talk about the last transition property, that is called as durability. Durability in a database transaction means that once the transaction has been committed and succeeded, that means that the data has been persisted, and even if now my computer has been crashed or power outage happens or database crashes itself, or that does not mean that your data is gone. It is present there and you would be able to get the data. So now if a database is stored on a single location, here durability means that the information has been saved to hard drive or an SSD. It might also include some additional way, that for example write ahead logs that is used to restore the data in case of a crash or data structure on the disk has been corrupted. In the case of replicated DB, durability means that the information has been successfully copied to multiple locations to make sure the information is secure, and the database has to wait until all the copies are complete before confirming that the transaction was successful. So now once we have these four properties that define the transaction, let's go and revisit our original money transfer scenario. So we had the user A and user B who were transferring the money. Now what we are going to do is that, so we used a statement to transfer the money from user A, and the second one from to transfer the money to user B. There were two statements and we executed them one by one. Now, for example, in a SQL database, there is a term to combine these two operations to a single transaction. That is called as begin transaction and the end transaction. That means that anything which is between the begin transaction and end transactions will be executed as a single unit of work that defines the transaction. So now we have discussed about what transactions are, why they are needed, how can we use them. Now let's turn things a little bit, that in which scenarios you are going to use it in terms of your system design interviews. So one place where you use is the like hotel room reservation. The scenario could be that, so you have a room and you have two concurrent users who are trying to book that room, and you want to make sure that the room is allocated to only one person, right? Here you can use some SQL database constraints and implement a transaction. The similarly you can use in a ticket booking system. So for example, like you're booking an airline flight reservations or ticket booking reservations systems or train booking systems, you want to make sure that the seat is allocated to only one particular user. The third place where you can use is in the scheduling systems. So for example, like you have multiple jobs that needs to be executed, and one way is that you can store those jobs in a SQL database, and you, whenever the request comes, you have a transaction that picks only the one job and assign it to one single worker. There are some other ways of doing it also, but this is what, like, if you have to use SQL database, this is the way, one way you can implement, you can use transactions to set up, to design that type of scheduling system. If you enjoyed watching this video, kindly hit the like button and share your thoughts in the comment section below. Don't forget to subscribe to our channel to stay up to date with our latest videos.